We're going to talk about section 2.4, transformations, and there's several different transformations we're going to talk about. Eventually, we'll start by what we call shifts, or what are formerly known as translations. So if we have something like y minus k equals f of x minus h, the h and the k are going to be our translation or our shift. Sometimes you will see this written with the k moved to the other side. So you may sometimes see it as y equals f of x minus h plus k. It's the same idea though. So if we start with something kind of basic here, suppose we look at our y equals the absolute value of x function, which we are familiar with, is going to be our v that opens up and has vertex at the origin. So if we in turn then look at something like y equals the absolute value of x minus 3 plus 2, then what that is going to do is it's going to move every point to the right 3 and up 2. So in particular, that vertex that was at 0, 0 is now going to be at 3, 2, and you want to make sure that you label that. It's going to be then a V, and these are supposed to look like 45-degree angle lines going up in each direction, and so there's our translated absolute value. If we have something like, say, the square root, so we know y equals square root of x, the parent function is going to contain the point 0, 0, and also contain the point 1, 1. So did the absolute value of x contain the point 0, 0, and 1, 1. And then if we're going to look at a translation or a shift here, and we look at y equals the square root of, let's say, x plus 2 minus 1, then this is going to be our same square root graph, but now that point that was at the origin is going to now be at negative 2 in the x and negative 1 in the y. So that point is going to be negative 2, negative 1. We'll go up 1 over 1, so that's going to put us at that point negative 1, 0, and then it's going to have that top half of a sideways parabola shape. And another curve that we should be familiar with is our y equals x squared curve. And so we know that's going to be that parabola that opens up. It too contains the point 0, 0, 1, 1, and also negative 1, 1. So if we look at, say, y equals, let's say, x plus 1 squared plus 2, then this is going to be the same shape, but that point that was at the origin is going to go left 1 and up 2. And so we're going to have the point negative 1, 2. And then we can go over 1 and up 1 and get another point, and left 1 and up 1. And that is going to be our translated parabola. I'm going to get a new panel, and we'll talk about reflections. So we can have reflections in either the x or the y. So that's going to look like y equals the negative of f of x. That will give us a reflection in the x-axis. And y equals f of negative x is going to be a reflection in the y-axis. So let's look at some examples. Suppose we have f of x is equal to, I'll do the square root of negative x first. So I'm going to put these on the same axis here, the original and then the reflection. So the original y equals square root of x, you will remember, is going to start at the origin. It's going to go up 1 over 1, and it's going to be that top half of a sideways parabola. So when we do the y equals the square root of negative x, that negative is going to reflect it in the y, and so it's going to look like that green function there. And in a similar way, we can look at, say again, y equals square root of x. So if we have y equals the square root of x, so let me do that one in yellow again. So we have y equals the square root of x, which we know is going to look like that. That's our parent function. And then if we do y equals the negative square root of x, that is going to be reflection in the x. If we in turn do something like the negative square root of negative x, that's going to be a double reflection, and the order you do it in doesn't matter. So we could, as we've seen here, start with our original y equals square root of x. We could then reflect it in the x, getting the green one, and then in turn reflect that in the y, and we're going to get something that goes down and to the left. So there's our double reflection. And we could have reflected in the, it doesn't matter the order, you could have reflected in the y first, and then when you reflect that in the x, it's going to still give you that blue graph. Okay, let's do some, I'm going to get a new panel up here, and let's do some that are mixtures of reflections and translations. So if we look at something like y equals the negative absolute value of x minus 3 and then a plus 4. So its graph, I'm going to look at the original absolute value. So our original y equals absolute value of x is going to be that v that has vertex at the origin and opens up. And then the reflection we'll look at next. So the negative absolute value of x would be reflected in the x, and so now we look at the green. And then finally we'll do the translation. So we're going to move that point that was at the origin, and we're going to move it right 3, 1, 2, 3, and up 4, 1, 2, 3, 4. So that vertex is going to be at 3, 4, and the shape is going to be that reflected opening down V. Okay? Let's do another piecewise function. So we can never get enough practice of this. More on piecewise functions. So I'm going to graph another example here, and then we'll do some other kind of crazy stuff with the shifting. So if we say that f of x is equal to, and I'm going to say one part is the absolute value of x plus 3 minus 1, and that's for x less than negative 1, and then negative of x for negative 1 less than or equal to x less than or equal to positive 1, and then a negative, parentheses, x minus 2 squared plus 1 for x greater than 1. So this is going to give us a chance then to look at all these things we just talked about in that same function, that is the reflections and the translation stuff. So this part of it right here is we're going to have our v, then we're going to move it to the left 3 and down 1. So the vertex is going to be 1, 2, 3 to the left. Down 1 is going to be a vertex here. Now I'm going to graph this v, but I'm going to stop it at x equals negative 1. So I need to know what's the y-coordinate when I cut this v off. So when we plug negative 1 in for the x there, we're going to get negative 1 plus 3 is 2. The absolute value of 2 is 2, minus 1 is 1. So that is going to be at the point negative 1, 1. That's the boundary of this absolute value. And that's going to be an open circle because of that strict inequality less than. So my v goes forever to the left, but is going to stop at that point negative 1, 1. At this point, we switch over to y equals negative x. Now, hopefully we recognize that's a line, slope negative 1, and y-intercept 0, but what I'm going to do is I'm going to plot these points. So I'm going to put the beginning and ending point and then connect those with a line segment. So when I plug in -1 for x, the negative of -1 is going to make that +1. So the starting point of that is going to be -1, 1, and that's going to be a solid dot because of the or equal to, and it just happens to exactly fill in that open circle that was part of the original graph with the absolute value. When I plug in the +1, we're going to get 1 comma -1. So 1 -1 is going to be also a solid dot, and then I'm going to connect those 2 points with a straight line segment. Then we're going to switch to the parabola part. Now that parabola is going to open down and have vertex at 2, 1. So I'm going to go 2, 1, and there's the vertex. It's going to be a parabola that opens down, but I'm not going to assume where it's going to, the beginning point. I want to plug in that 1. So when I plug that 1 in for x, we'll get 1 minus 2 is -1. -1 squared is +1. The negative of that is -1 plus 1 is 0. So I'm going to get 1, 0 as the place where this parabola ends, and that's going to be an open circle. And so there's the, or I guess actually you can think of it as the beginning. So our graph is connected up until we reach that point at x equals 1 where there's a break in the curve. Okay, I'm going to get a new panel here. Let's do a different kind of problem here. I'm going to give you a table of values. So here is our function, and we're going to say that x is going to be -2, -1, 0, 1, and 2. And the f of x values are going to be 5, 3, -1, 1, and 2. So our challenge is, can we get the table of values that will work for the function f of x minus 1? Now, we have to be careful, and the way to think about that is we're going to choose a value of x so that when we subtract 1 from it, it's going to be equal to this value, -2, because that's part of the domain of f. So I can only evaluate f at these known values, these values that are in its domain. So I have to choose an x here in the domain of f of x minus 1 that will then, after we subtract the 1, give us values in the domain of f. So to make this be equal to a -2, I'm going to choose x to be -1. Now, -1 minus 1 is -2, so that means I'm going to evaluate f of -2, which our table tells us is 5. Crazy? Let's try another one. Now I want to come up with an x value of -1 to go into the function f. So I'm going to choose x to be 0, so that 0 minus 1 is -1, and f of -1 is going to be 3. Similarly then, I'm going to plug in 1 for x. 1 minus 1 is 0. F of 0 is -1. That'll make this -1. And then I'm going to plug in 2. 2 minus 1 is 1. F of 1 is 1. And then I'll plug in 3. And 3 minus 1 is 2. And f of 2 is 2. And that's going to be our table for f of x minus 1. Crazy, crazy, crazy. Let's do another one. Let's do, say, x, and then I'm going to say h of x, and h of x I'm going to say is f of x plus 2 minus 3. So again, what we're going to do here is I'm going to have to eventually try to evaluate this in the function f. F has for its domain only these 5 values given up here. I'm going to switch colors here. So I'm going to pick a value of x that when I add 2 to it will be -2. So I'm going to plug in then 0. So 0, I'm sorry, that's not going to work. I want that to be equal to negative 2, so I'm going to choose x to be negative 4. Negative 4 plus 2 is negative 2. F of negative 2 we can see is 5. 5 minus 3 is going to be 2. That's the value of h. Crazy. Now I'm going to try to generate a negative 1, and so we're going to pick x to be negative 3. Negative 3 plus 2 is negative 1. F of negative 1 is 3. 3 minus 3 is 0. And then I'm going to plug in negative 2, because negative 2 plus 2 is 0. F of 0 is negative 1. Negative 1 minus 3 is negative 4. And then I'm going to plug in negative 1. And negative 1 plus 2 is 1. F of 1 is 1. 1 minus 3 is negative 2. And finally, I'm going to plug in 0. And 0 plus 2 is 2. F of 2 is 2. 2 minus 3 is negative 1, and that's going to be our function. Crazy, crazy, crazy. Okay, got one more for you. I'm going to give you a function given as a graph, not a table of values like we did there, and not an equation like we did earlier. So here is our the values of x and y. I'm going to say the curve is going to look like a little kind of a triangle or V thing there, and then a taller upside down V. This is our function f of x, and we're going to see, can we graph y equals negative f of x? So that is going to be reflection in the x, so that would look like, I'm going to do dotted because I'm going to try to fit a couple more on here. So I'm going to have to go down to there. So there is the graph of y equals negative f of x. And then I'm going to graph on that same axis f of negative x. F of negative x is going to be reflection in the y. So that triangle on the right is going to become a triangle on the left. And the triangle on the left is going to become a triangle on the right. And I'll see if I can squeeze in one more here. Let's see if we can do y equals f of x minus 2. So that's going to move everything to the right 2. So this point that was right here is going to get moved right 2. And this point is going to go right 2. And the origin is going to go right 2. And this point up here is going to go right 2. And this point on the x-axis is going to go right 2. And so we're going to get something like that. All right. See what you can do with homework number 12.